Welcome to my channel. Today I got some nice integral question in here. Integral of sine squared nx over sine squared x from 0 to 5 equal to n times 5. Right. As usually, please pause the video and try. Right. Let's see. I consider in plus 1 minus in 0 to 5 sine squared n plus 1 times x over sine squared x minus sine squared nx sine squared x dx. Right. If I evaluate that, I got the telescoping series, and finally I am able to calculate the summation of that series. 0 to 5, common denominator is sine squared x, and here I got sine squared n plus 1 times x minus sine squared nx. 2 sine minus sine cos plus this 2n plus 1 over 2x sine minus x over 2 into 2 sine is plus 1 2n plus 1 over 2x cos x over 2 dx. Right, because this is a difference of 2 square, sine squared minus sine squared. Actually we know that the relations sine c plus sine d equals to sine c plus d over 2 cos c minus d over 2, and sine c minus sine d equals to cos c plus d over 2 sine c minus d over 2. I use that relations to here, and finally I got this answer. And we can simplify a little bit to this one and this one. Yeah, sine 2n plus 1 into x, and if I consider this 2, this sine and this cosine, I have got sine x over sine squared x dx. I can cancel out these terms. Finally I end up with sine 2n plus 1 times x over sine x dx. Right, finally I got that relation, in plus 1 minus in equals that one. So if I evaluate somehow this integral, I have the telescoping series. To evaluate that, I consider that is Jn. Right, I take that is Jn. Okay, I got the relation in plus 1 minus in equals Jn. Right, I'll take this first. Let's say Jn plus 1 minus Jn, right? I'm building another telescoping series, equals 0 to 5, integral of 0 to 5, and sine, I put n as n plus 1 in here, so I got 2n plus 3 times x minus also this one, psi 2n plus 1 times x over sin x dx. Right. Simplify that according to this formula. I got 2 sine minus sine. I got cos this angle plus this angle, 2n plus 2 and 4n, 3 plus 1 4, and I divide by 2, 2n plus 2 times x, right? Cos sine this angle minus 2n and 2n cancel out, 3 minus 1 2 divided by 2, I got sine x over sine x dx. Those are cancelled, and 0 to 5 I got 2 outside from the integral, cos 2n plus 1 x dx, integral of that one. I see sine 2n plus 1 x, 2n plus 1, 0 to 5. Yeah, this is 0, right? Okay. I take another sheet. Finally, I end up with jn plus 1 minus jn equals 0. Right? I evaluate that. I obtain that relation. So I can write jn plus 1 equals jn, right? According to this, jn must be equal with jn minus 1, jn minus 2, and so on. Finally, I end up with j naught, right? What is j naught? As you remember, jn is jn 0 to 5, 0 to 5, as jn, yeah, it's here. Sine 2n plus 1 x over sine x dx. When I put n equals 0, I got j naught, and that's supposed to mean n equals 0, I got sine x over sine x dx, integral of 0 to 5, integral of dx from 0 to 5, x 0 to 5 is equal to 5. So this must be equal to 5. So according to my first relation, right, as you remember, I got equation as 1 is in plus 1 minus in equals jn. Right? Just now I figure out jn equals 5. Right? So I can write in plus 1 minus in equals 5. Okay. Now I write like that, I1 minus I0 equals 5 according to this. I2 minus I1 equals 5. I3 minus I2 equals 5, and so on. In minus 2 minus in minus 3 equals 5. In minus 1 in minus 2 equals 5. in minus 1 equals 5. Right. When I add all of those terms, these terms are cancelled out. I1, I2, I3, and these are. There are 1, 2, 3, 4, 5, 6, and so on. There are n lines, so there must be n times 5. I end up with in minus I0 equal n 5. So if I evaluate I0, I have the answer. Okay, take a look. I take this relation as 2. In is 0 to 5 sine squared nx over sine squared x dx. When I put in as 0, I0 equal 0 to 5, sine 0 is 0 over sine squared x dx, integral of 0 from 0 to 5 also 0. So I end up with I0 equals 0. So that means In equals n pi. What is In? Of course 0 to 5 Sin squared nx over sin squared x dx in phi. Yeah, that's the final result. Yeah, that's it.